Hello all, welcome back to lecture 3 part C. In this part we are going to do some hands-on on linear regression using Python. So now first we will open our Jupyter notebook. Here I'm going to open Python 3 kernel. So the first thing we are going to do is we have to first open we'll put some headings, say linear regression using Python. Okay, and then I'm going to write some more markdown, say import some packages. So what are the packages we are going to import? We are going to import NumPy, pandas. For plot, we are going to import some matplot libraries and scikit-learn or sklearn. So from import, we are going to import NumPy as np, then import pandas as pd, then import matplot library, matplotlib dot particularly pyplot we require. We don't need to import everything as plot, and then from sklearn import linear model, linear underscore model, and from sklearn dot, actually there is an n missing, sklearn dot matrix import r2 score. So r2 score is going to calculate the r squared. We have not studied the r square yet in the theory part. We are going to discuss the model evaluation of the r square very soon in next few lectures. But we will figure out in this Python hands-on how to calculate r square from a fitted model. So let us run this. So all the packages are now imported. So let me try to increase the size a bit. I hope this size is okay with you guys. So first provide the file path, so fp equals to, so I have to give users downloads. So you have to, in this path you have to give the path of the emptycars.csv file. So here the final file is emptycars.csv, and you have to give the full path so that it can be called, and then read the CSV files. So here's read the CSV files, and then data. I'm going to read the data to pd dot read underscore CSV, and I have to give the file path and separate it by comma. So without any difficulty, data is being read. Now we are going to check out the first shape of the data. Check out the shape of the data. Okay, so data dot shape is 32 cross 1. So we have, in this data we have 32 rows and 11 columns. So check out first few lines. Check out first few lines of the data. Okay. Sorry, it has to be a markdown. Yeah. Now data dot head is the one. So data dot head gives you the first 5 lines of the data frame that you are handling. So here miles per gallon is going to be our target variable, and cylinder displacement, horsepower, rear axle ratio, these are going to be our independent variables. Now first what we have to do, we have to do some EDA and visualization. EDA and visualization. So I will put some mark on that, maybe a third. Now so first we make some scatter plot. So data DOT and data MPG. If I run this, so you can see this, it is plotting the data, but it has not given any x-axis or y-axis. So we have to give a name to the label, or we have to provide a label to x-axis and y-axis. So plot dot x label. We have to say what is there in the rear x-axis. This is rear axle ratio, and we have to give a font size, maybe 16, and similarly we have to give miles per gallon. So now if I run it, sorry, we have to be X level, there has to be spelling error, Y level. Yeah, now it is fine. So let me just a little bit smaller. So on the Y axis we have miles per gallon, and on the X axis we have the rear axle ratio. Okay, so if you don't put this semicolon, you will see this text 0.5 miles per gallon is coming, the last, some message about the last line. But if you put this semicolon here, then you will see it will not appear, and it will look little better. Next, we are going to fit the linear regression model with rear axle ratio. So we'll write fit linear regression model using rear axle ratio. So maybe you put it like this, you can see it will looks like the variable itself. And some theory you can put about, first we have to put here a markdown, and then you can say that, okay, miles per gallon is a function of alpha plus beta times 15 plus per epsilon. So if you run it, so you can see miles per gallon is a function of alpha plus beta times rear axle ratio. So you can put a little bit of space so that you have the things much more clearly, nicely done. Our job is to calculate the value of alpha and beta from the data. So first thing is, what is our x? Our x is prayer axle ratio. So we will call it as a array. We'll define it as array, and y is miles per gallon. Now if I just say run x, you can see this is as an array, or y, you can see this is a single array. It is being read as a single array. Now next, first we have to define the linear regression from module from the sklearn. Define, or we just write define linear regression model from linear model of sklearn package. So this is our first task, and how we define this: ln equals to linear model. So remember that in the beginning we have, from sklearn we have imported linear underscore model. From linear underscore model we are defining linear regression. Okay, and we defining it as a ln. Okay, and now we are going to fit our model, fit m1 equal to lm dot fit x equal to x and y equals to y. So it fitted the value, and now from the model, if we just say intercept underscore, so this is our intercept, this value is our intercept, and similarly if we just say beta equal to fit underscore m1 dot coef underscore, it will give you the coefficient value of beta 7.6782. Now we are going to calculate the y hat values. Y hat values are intercept plus np dot product between x and beta. So if we just then write, so these are our fitted values. Okay, these are our fitted values. Now what we want to check that we also learned that this model can be fitted using OLS method, and in the OLS method, using OLS method also we can calculate how the value of alpha and beta, and we will use OLS method to calculate the value of alpha and beta, and we will check if the value of our estimated method using OLS is matching with the sklearn's estimated values. So estimate alpha and beta using OLS and check the values against the sklearn estimates of sklearn. Technically they should match, but let us try to check it out. So what is our OLS method? OLS method is y equal to x beta plus epsilon, and OLS estimated is at beta equals to x transpose x inverse x transpose y. So we are going to use exactly this formula to estimate the values of alpha and beta. Our estimated beta hat will be a two-dimensional vector, with the first component of the vector would be the estimate of alpha or intercept, and the second component would be the estimate of slope. So let us try to estimate the alphas and betas. So first let us see how our x looks like. So our x is a simple 32 dimension vector, or in a matrix terms is a 32 cross 1 column. So we have to first define our design matrix. So first define the design matrix X. Okay, so first we need n. So we know n dot data dot shape gives us the value of 32. If I just do 0, it will give me the first component, that will give me the value 32. Let me to put that in n. So now I'm going to define intercept column as np dot ones n comma 1 if you just run it. And capital X equal to np dot h stack. So first is intercept column comma x. Now if you look into it, you can see it is a 32 rows 1 comma 2 column. So first column is all intercept and the second column is all rear axle ratio. All right, now we have to compute the x transpose. np dot transpose is t. So this is our x transpose matrix, and then we have to calculate the x transpose x matrix. So basically this is a multiplication between x transpose and x. So it will be np dot matrix multiplication. From numpy we will call this matmul function, and we will just provide x2 function that we want to multiply, and this is my final x transpose x. Now what we have to do, we have to calculate the x transpose x inverse. Inverse is, for that, from numpy linear algebra module, we have to call the inverse, and we have to provide x transpose x, and so this is our x transpose x inverse. Now if we look at it, it is x transpose x inverse x transpose y. Now x transpose is a 2 cross n and y is a n cross 1, so x transpose y will be 2 cross 1 product. So let us calculate the x transpose y. So np dot matrix multiplication x transpose and y. If I do that, so this is my x transpose y, so I can just calculate that. And now what I have to do, I have to just do another matrix multiplication, np dot matrix multiplication between x transpose x inverse and x transpose y. If I do that, so this gives me the beta hat. So beta hat is this. Now this is the OLS estimate. We need to check against the value of A of integers from the sklearn. So from sklearn we just call this and fit m1 dot OF. So let us run this. So these values are, the first value is the intercept value, negative 7.52467. So it is exactly matching the OLS method with the sklearn. So sklearn itself is also implementing OLS method, ordinary least square method, and slope is 7.678. So we see how you can calculate the analytic solution using OLS method for simple linear regression. Now what we will do, we will now since we have the alphas and betas, we will draw a straight line through these scatter plots. For that, what we have to do, we have to write a abline function. So in R there is a nice function called abline. We will write a small function called abline, and we will call that, and we will use that to draw the straight line through these scatter plots. So we will draw the straight line through the scatter plots. Okay. Now for that, AB line slope, comma intercept. First we have to define the axis. So we'll call the axis from plot dot GCA, and then we will check out the x values, that np dot array from the axis we will get the x limbs or x values, and y vals will be simply, so this could be the x vals, this could be the y values, will be simply intercept plus slope times x values, and then plot x vals comma y vals, and we want dot y. So let us, the abline is ready now. What we will do, we will just take this pieces of line here, and without disturbing it, we will just go and plot it there, and then AB line is equal to slope is, so this is the value of slope equal to this comma intercept equals to, so this is the value of intercept. So let me just run this. Now you can see this is the OLS fitted line through the scatter plots. Finally, we will do a little bit of model evaluation. I'll just introduce the concept, but using, how can you do this using the model evaluation, because model evaluation is extremely important component. Whenever you are fitting a linear regression, you should do a model evaluation. So let us, and R square is one of the metric, very popular metric, and we have imported R square, R2 score from the matrix, sklearn matrix module. So we will, what we will do, we will just call that R2 equal to R2 score y comma y hat, and then just check it out. So it is R square for this fitted model is 46.39 or about 46.4%. So that means about, if you look into the miles per gallon, whatever variability you have, about 46% of the variability can be explained by the rear axle ratio, which is a very good thing. And so we will talk more about R square in the coming lectures, and you can do a lot of things. We will with the sklearn in Python. So we will stop here today, and next we will see you at lecture 4. Thank you very much. Bye.